Check my settings. So we're going to do interval notation. So interval notation. Okay. Use parentheses for greater than or equal to. Let's put some parentheses. Like one of these guys or one of those. And that symbol is like greater than or equal to. Yeah, cool. Also, you have less than or equal to. Let me see if I did this right. Listen, oh wait, this is less than equal to this. Let's put some stuff in there. Like, let's put x greater than or equal to 3. That helps. X greater than or equal to 3. And here we'll have x less than or equal to 3. Let's make it different. Let's make it 4. So you can equal 4, or you could be any number less than 4. Okay, use square brackets for, oh wait, I'm confusing things. I'm sorry. Thanks. Okay, greater than or equal to. I've made a mess of things. I think we should just start over. Okay, I will stick with the parentheses, so we will use parentheses. These ones. Okay, these are actually supposed to be used for strict inequalities, like strictly less than, strictly greater than. Okay, so this says x less than 3, which is a strict inequality, or we'll do x greater than 4. Okay, now we have the right notes. All right, parentheses, when it's just strictly less than or strictly greater than. It's square brackets that you use for something like greater than or equal to. Square brackets are for, let's put some really quick. Square brackets. Let's just, So if we had greater than or equal to, I'm going to use a square bracket. X greater than or equal to 0. So x is greater than 0 or equal 0. We could have less than. So we'll have 2 less than or equal to x. Okay, 2 is less than or equal to x. Another note, we will use closed circles for square brackets. Use open circles for parentheses. Or you could say use closed circles when you have greater than or equal to, less than or equal to. Open circles are for strict inequalities, strictly less than, strictly greater than. It will both make sense. And I'm just also going to note that this is when you're drawing a graph for the values of x. Okay, last note, and then I'll do a lot of examples, is that positive and negative infinity are always going to have parentheses. Infinity. So x will not equal negative infinity, so it's not going to be like included in the set as a number. It's not a number, so it'll have parentheses on it. Okay, any questions? All right, let's do examples. We will write the following set in interval notation and draw a graph. We have the set, so you start your set with a curly brace of x values such that x actually, we're going to put a little extra here. We're going to have 1 less than or equal to x less than or equal to 4. 1 less than or equal to x less than or equal to 4. Let's do the graph first. There's only one variable, so you don't need an x and y, just the x axis here, like a real number line for x. We need a place for 1 and also a mark for 4. Let's go like 0. Okay. X is greater than or equal to 1, so we will include 1. We put a closed circle on that. X is greater than or equal to 4, so you can include 4 with this little piece of an equal sign here, and put a closed circle here. And then you're looking for values of x that make that statement true. So we can test some numbers. I think we'll do that. So you would have test intervals. There's a test interval that goes from -infinity to 1, an interval from 1 to 4, and then from 4 to infinity. So we can test something like 0 is on that side. Maybe we'll test 2 for this interval. And then we'll test like 5 over here. Okay, put 0 in here and just see if it's true or false. One is not less than or equal to 0. It's greater than 0. Okay, I'm going to do this testing for the first few examples, but after that, I think we'll just talk through the examples. But we've gotten this value is not in the set, so nothing on this side of 1. Let's test a number between 1 and 4. I picked 2. So we're putting 1 less than or equal to 2 less than or equal to 4. 1 less than or equal to 2. Yep, 1's less than 2. Also, 2 is less than 4. This is good. This is true. Okay, so this is in the set, and you have all the values between 1 and 4. I was testing any number between 1 and 4, it would have been true. It would have made this statement true. Okay, I'm going to do a test on some number greater than 4, just to check this side. This is false. True. Okay, we've got 1 less than or equal to 5, which is true, but less than or equal to 4 is not true. is greater than 4. It's not less than or equal to 4. So that's a false statement for this area. It does not work. This side's false. So that was the interval, was where x values are, and I'll write it in interval notation. So it's 1 and includes 1 from that symbol. Let's put this in actually. Here. Okay, so you had this x, switch that 1, switch the x. This set is equal to the set that goes from 1, including 1 with a square bracket, and then over to 4. With the equal sign part, you include 4 with a square bracket. And that's like your answer. Okay, so new problem. New example. We will write the following set in interval notation. And draw a graph. Let's draw a graph. So our set is the set of x values, x, such that, let's see, 10 is strictly less than x. And x is less than or equal to 20. I'm going to start with the graph. Okay, so we need 10 and 20 somewhere on this number line. I'm gonna make this like 0, 5, 10, 15, 20. 10 has an open circle because there's a strict inequality. 20 has a closed circle. It's gonna be less than or equal to 20. So I think I do want to go through the testing process again. You have a test interval from negative infinity to 10, a testing interval from 10 to 20, and then last interval is 20 to positive infinity. Let's just pick 0 and 15. But some number from here to here, something in there, and then somewhere past 20. Okay, so let's put 0 in here. 10 less than 0. That's not good. Less than or equal to 20. So this part here is a problem. Okay, leave it at that. So that is not a solution, and nothing on this side of 10 is in the set. Okay. 15. 10 less than 15 less than or equal to 20. So 10 is less than 15. 15 is less than 20 or equal to. Still true. So this is true. And everything in here is true. Okay, we are still going to check 25. Yes. 10 less than 25. I mean, where's my thing? 10 less than 25. Less than or equal to 20. So this part here is not true. This is false. False part. It's not going to use that. Okay, let's write the answer. Write the set in interval notation. So I'm going to bring back the original set. So we had the set of x such that 10 is less than x, less than or equal to 20. And we write it as set that goes from 10 to 20, not including 10, or not including 10. Parenthesis, you do include 20, or solid dot. 20 is in the set, so use a square bracket. And that would be your answer. Maybe like okay, so I think I'm going to stop doing the testing, but you can always stop and test. Okay, we're back. Sorry about that. So I was trying to say, if you're ever not sure what x can be, you can stop and do a test. Okay, let's do a new problem. Okay, let's change it up. We'll say, draw a graph of the following set and write the set in interval notation. So I have the set of x. Set of x such that 6 is less than x and x is less than 8. Okay. So graphing this set on and around for x. We need, okay, good. Sorry about the internet connection, but it should stay. Oh, we forgot to record. Oh no, the recording's still going. Nice. Okay, so got my graph ready. We have an open circle on 6 because there's a strict inequality. Also a strict inequality for 8. You want all the values of x that make that statement true. So x is between 6 and 8. Okay, and I'll put this note up in a second, but we always go from left, or from the small number on the left to the larger number on the right. So 6, and you don't include 6. 8. So that parenthesis comes from not including 6. The strict inequality, same for 8. Okay, so I said that when you graph an inequality, let me see. When you write a set in interval notation, the smaller number goes on the left. Cool. I've got another set. So, new example. We'll write the following set in interval notation. And that's it. I have this set, so curly bracket starts your set. You have your x values such that x is greater than or equal to 3. That looks funny. Maybe let's make it 4. So again, the set of x such that x is greater than or equal to 4, and then close the set. I still will draw a graph. It helps me to write the set in interval notation. I'm going to plot 4. X can equal 4 and be any number greater than 4. If you wanted to test this one, you would test x values on this side of 4, between negative infinity up to 4, and then you can do a test on the interval that goes from 4 to positive infinity, and you'll see that this side would give you false answers, this side is true. Okay, so you include 4 with a square bracket, and you do the interval notation. Okay, 4 is included. And then you're going over to positive infinity. Positive infinity always has a parenthesis around. That's the answer. Okay, so I will continue to do some examples. For this, might skip a couple examples. Yeah, let's skip to here. Have x less than or equal to 5. So this set. X such that x is less than or equal to 5 is values going from negative infinity up to 5 and including 5. And sometimes to get that set, it helps to draw a graph. Like I'm trying to visualize a graph as I write this down. Okay, got 5. You can include 5. And if you want to test values of x, you could go on this side of 5 to negative infinity. You could test some number greater than 5. And the values that are less than 5 will be true. So on this side of 5. You get a true statement here, and your set starts from the smallest value, so negative infinity, on the left, goes up to 5, includes 5 with a square bracket. Let's try something new. Well, sort of different. Right. Okay, so we're starting new set. The set of x values such that x is less than 1 or x is greater than 2. Let's make x greater than 5. And then close that set. I want to do the graph first. Down 0. Started a graph. I need 1 open circle on 1. 5 also has an open circle. If you want to test values for x, it would be some number in the interval that goes from -infinity up to 1. From 1 to 5. You could pick a number, test that number, and then you can check that last interval from 5 to positive infinity. You could pick some value, see if it's a solution, or see if it makes this statement true. All right, so x is less than 1 here. X greater than 5 is right there. Let's write the set. So we'll go from the smallest number, -infinity. Let's do an equal notation. Starts with -infinity. Go over to 1. Don't include 1, so put a parenthesis around 1. Or you can look here, parenthesis around 1. Okay, union the set with that set. So union set that's starting at 5, going to positive infinity. Don't include 5, so we have parenthesis here. Well, you guys have seen union. We've talked about this already. So. Okay, one more of these. So okay, and write it in interval notation. I've got this set that goes, the set of x values such that x is, let's go here, less than or equal to -5. Go pick it up. Okay, or x is greater than -1. I'll start with the graph. Number line, x, 0. Let's switch these. Okay. -5 will be included with this x less than or equal to -5. Close circle. And those x values are going to go to negative infinity. And then greater than -1. Let's open circle here. Then the interval is the set that goes from -infinity to -5, include -5 with the square bracket. This set unioned with that set. That goes from -1, not including -1, over to +50. All right, I think that's good. Any questions or concerns? Okay, let's do something different. So, changing topics a little bit. So we've got this variable x, and we have different ways to draw. Let's see. I'm just going to start fresh board. Okay, that's better. So I will just go into the two topics, or I guess one of them will only come up today. We'll do the next one the other topic next time. First one is bar graphs, other one is histograms. So use a bar graph. To organize qualitative data. Okay, we use a histogram to organize quantitative data. Just as a side note, I would probably be clear on the problem to say do a bar graph or just tell you to make a histogram. I wouldn't try to ask like which one would you do for this variable. That's not really my goal. Okay. Today I think we'll draw a few bar graphs, and then next time we'll try to do some histograms. Construct a bar graph for the following data. Okay. We're going to do red, orange, yellow, green, blue, purple, and have R for red, O for orange, and so on. And then the frequency. Okay, we have 2, 5, 6, 1, 3, 4. And I'm going to need to erase this, so I'm going to put it in the, type it up in the chat so that you guys have this info. To everyone. Okay. Last one. Okay. Let's clean this up. Too much. So you can have your categories and then the frequency, or you could do frequency with categories. It's up to you. I like to put the categories over here. Then we'll mark red, orange. I just remembered, I forgot to put a little notes. I'll put the notes here in just a second. Red, orange, yellow, green, blue, purple. Okay, I forgot to mention that if you have a bar graph, bars don't touch. For a histogram, the bars touch. Okay, so we have 1, red was 2, so around red we have a bar, goes up to a height 2. Orange has height 5, and it's a bar that doesn't touch the other one. Yellow is going up to a frequency of 6. Okay, green is height 1. Blue is height 3. Purple goes up 4. Cool. Let's do one more. Construct. Okay, construct a bar graph for the following frequency distribution. Categories and then frequencies in this table. We have time. Cool. We've got 2, 4, 6. Okay. So 2 occurred 15 times. For 4, we have the frequency 20. This one's 10. This one's 10. Okay, bar graph is here with this side for one of these. Like, I like to put the categories on the horizontal axis, and then the frequency is on the other axis. So we have 2, 4, 6, 8, 10. And then we need 20 on this graph, so let's make this 20. Halfway will be 10. Half that is 5. 5, 10, 15. Okay, so the category 2 is a bar around it, and it goes up to a height of 15. 4. It's a bar around it that doesn't touch the other bars and has height 20. Cool. 6 has height 10. Okay. 8, also height 10. Around 10, we go up 5. Okay, I think I'm going to stop here for today. So that's the end of the notes. And